Hello, everyone, and welcome to today's session, Architecting for BI and Analytics with AWS. My name is Archana Krishna, and I'm joined by my colleague, John Miller, both of us are business intelligence and analytics consultants at Thorogood, and we're typically based in our offices in Philadelphia. Today, of course, we're joining you from our respective homes. A quick introduction to the structure of today's session. We'll do an introduction to Thorogood. I'll then talk a bit about architecting for the cloud. What are some of the key considerations and questions that you need to keep in mind? John and I will then walk you through an end-to-end architecture based on some of our examples and experience working with customers in designing BI and analytics solutions. So, quick introduction for those of you who are not familiar with Thorogood. We are a specialist business intelligence and consultancy firm. We're an independent company and operate globally. We've got offices in London, New York, Philadelphia, Boston, Singapore, Sao Paulo, and Bangalore. We help our customers with a wide range of services across the BI and analytics spectrum, so right from BI and technology strategies and roadmaps, end-to-end implementation, and training and support. Our focus with all of our customers is combining the power of technology and our understanding of analytical tools and techniques with a continuous focus on delivering to business goals and objectives. As I said, we are an independent company in that we don't align with one particular technology. We work and partner with most of the biggest players in the market, cloud providers, analytics tools and technologies, and reporting tools. We focus on the enterprise adoption of these technologies and help our customers integrate across many of these tools successfully. We do have a vast amount of experience delivering AWS projects with our customers. So some sample projects that we've been involved in are architecture, evaluation, and recommendation, the definition of strategy and governance framework for data lakes and going on to implementing them, migrating a lot of on-prem workloads to the AWS platform, and much more. If you do need any help or if you're interested to learn a bit more about some of the work we've done, feel free to reach out to us. So moving on to today's session, we do know that in today's time, with digital transformation at the top of the agenda for most, if not all organizations, moving to the cloud and realizing its benefits is a top priority. Particularly in today's times, with COVID-19 and most business operations going through a drastic change, many of our customers have actually accelerated this move to the cloud. Now, this is by no means a comprehensive list, but some of the benefits that organizations are looking to realize are a better control and management of their spending on IT and infrastructure. You will notice that I've not just said reducing spending, because whilst you may very well end up saving costs when you move to the cloud, it does require close monitoring and optimization to make sure you're putting in place best practices to achieve that goal. High availability of systems, and if there is a disruption, just being able to quickly recover from that and get back to your business as usual with full connectivity. The ability to use resources as and when needed, and to perhaps turn up performance and power based on your specific demands. So, for example, you may want a higher performing system during peak processing periods or peak reporting periods, or when, let's say, you're pushing through large data volumes through an analytical model as part of like a one-off exercise. So just being able to flex your performance and achieving the right level of performance is key. We're all probably familiar with terms like Agile and Devops. One of the common principles of this is to be responsive to your customer demands. Your customer demands may be coming from your internal IT stakeholders or business stakeholders or just external consumers. Putting in place efficient operations provides a massive advantage. And finally, security. Putting in place the right security controls that are compliant with your organization standards and government standards are pretty important, particularly with the right level of oversight. Now, these 5 pillars across the bottom, that's cost optimization, reliability, performance efficiency, operational excellence, and security, form what's known as the 5 pillars of AWS's well-architected framework. So really, just to think about these topics when you are designing an architecture helps deliver a robust and a stable platform. So what are some of the considerations when you are moving to the cloud? The first thing that you'd naturally think about are the tools that support your needs around your data sources. What are the data sources that you work with? How often do they change? How often do you need them to update? Where do you store your data? What sort of data volumes are you looking at? What are the data transformational rules and manipulations that are being used in your applications? Are they applicable to all users? Are there synergies? are you currently using or looking to use like analytical models or data science algorithms? Are there specific tools of interest? Do you have any existing investments in BI reporting and analysis, and are you looking to leverage that as part of your move to the cloud? Most BI reporting solutions tend to use some sort of a semantic layer, be it a relational model or a multidimensional model. So what do you have, and how does that translate into your cloud architecture? And finally, how do you make your data more available and accessible to all users within your organization? So thinking about tools that support these needs is obviously important, but equally important is thinking about the people and process side of things. So just understanding who your IT and business user groups are. What is their current situation right now? What are their pain points? And what are some of the things on their wish list? What kind of data sets are being used by the business right now? So is it all of the data that's just coming in from your finally processed reports and semantic layers, or would they like to get access to some of the more raw data that they perhaps like to play around with? Any architecture that you define needs to support all of the different usage patterns. So just getting a better understanding of that does help shape your strategy and final architecture. What we've found with our customers is that just understanding the skill sets of all of your existing users and thinking through how you would leverage that even though your architecture is changing and you're moving to a new way of working, that can be pretty valuable, so you're not really having to start from scratch. And finally, from an IT side of things, how to best make use of the DevOps process and tools to achieve efficiencies in your development and release lifecycle security controls. And finally, having the right structure, processes, and framework in place that meets the needs of your organization. So all of these factors will help you in developing your cloud architecture, whether you're just starting off or well into your cloud journey. So now let's look at how AWS supports these cloud architectures and what are some of the offerings it has. You're probably not going to be surprised with this, but there's a ton of offerings that are available. These are just the high-level sort of categories, and there are several services that fall under each of them, and that list of services is continuously evolving and changing. So if you look at the things that are available that may perhaps relate to a BI and analytics use case, within the analytics section, there are a ton of tools that are available for querying, processing, and reporting data, and many more options from a machine learning perspective, and that's not even the whole list over there that I've got up. A few different options from a storage point of view, so you'll see things like an S3 storage, which is a data lake-based storage, and there is a completely separate category for databases, so there's obviously many more offerings there. So it's understandable that it could be pretty overwhelming to identify the right tool that meets your specific need, and more often than not, there will be several tools that meet your individual needs. So how do you go about navigating this landscape? What we thought would be useful is just to walk through an end-to-end architecture, which covers some of these use cases and patterns that we've seen are pretty common to BI and analytics requirements. Now, this is by no means a one-size-fits-all kind of solution. It may work for you. There may be certain components that work for you, and you may need to swap out certain other tools. But this is really intended to provide a starting point to help you think through what some of the common requirements may be and which of the AWS services would deliver those needs. So where do we start? In this case, I'm going to start off with an AWS S3 component. So S3 is a data lake structure, S3 standing for Simple Storage Service. What is a data lake? It's a low-cost file storage system that is capable of storing any kind of data, so be it structured data, semi-structured, or unstructured data. The purpose of this S3 data lake is to serve as that central data repository for your organization, sort of like the single version of truth. Now, within a data lake, what we found to work quite well is building out separate layers, be it physical layers or just logical separations based on how useful or mature the data is for downstream consumption. So we're going to start off with a raw layer, which we've envisioned to be just an exact copy of the data that's coming in from the source. Absolutely no transformation, and just an exact replica. You may now want to cleanse and prep the data to make it a little more usable. Data sets in these intermediate stages go into what we're calling the process bucket. And finally, we've depicted an output layer that has more consumable data, both in terms of the actual data content as well as structure. you'll typically see that the data over here is enriched with common business calculations or master data attributes, just so it's available centrally and doesn't need to be rebuilt and re-engineered by every downstream application or any other user pulling this data. I should say that we've got an indicative representation over here, and it doesn't mean that only the output data is consumable by other applications or that you always have to have 3 layers, because in your particular use case, you may need a little more differentiation. So, you may have 4 stages, for example. But the overarching principle is that setting up and defining some layer of this organization makes data more easily accessible and consumable. So now that we've got this data lake designed, we'll take a step back and look at the data sources. I've outlined different data sources here, so you may have things like structured databases, data coming in from other cloud providers or software as a service providers, and some more semi-structured or unstructured data coming in from social media or live streaming services. I'm now going to hand this over to John, who's going to talk you through how this data flows from these data sources and we push it through the data lake.
So today I will be presenting the pathway that your data will take through the AWS architecture to reach your business end users. Before I move through the architecture, I want to first say that this is only an example architecture using AWS offerings that we believe would work well under most circumstances. It is always important to consider the use case for the system and the skill set within your company when making decisions about your architecture. Please feel free to reach out to us if you have any questions about setting up an AWS architecture. So when thinking about a complete end-to-end architecture, the first question is, how do you get data from your source systems into your data lake? This first move into the data lake typically focuses on taking the source data as is and replicating it into the raw layer in the data lake, ideally with no processing. Amazon offers multiple tools to accomplish this task. On our diagram, we have AWS Database Migration Service and Amazon Kinesis, which are each meant for a particular use case. Over the next 4 slides, I'll discuss these 2 offerings and a few other common options we think would be useful in most circumstances for getting data into the data lake. The first one that I'll talk about is AWS Database Migration Service, or DMS for short. We have used DMS to run initial data migrations from a variety of source databases, as well as ongoing replication on a near real-time basis. It is fairly simple to set up and monitor, and if your source data is already being stored in a database, it would probably make the most sense to use DMS in your architecture. Next up is Amazon Kinesis. Amazon Kinesis is useful for processing real-time data and enables you to start analyzing data immediately instead of waiting for all data to load. It is best suited for bringing in social media type unstructured data or other unstructured data sources. There are different types of Amazon Kinesis tools depending on your use case. They have Amazon Kinesis video streams, which is useful for when you need to stream video for processing. They have Amazon data streams, which captures data in millisecond intervals to be processed and displayed in real time. And then they also offer Amazon Kinesis Data Firehose, which is like Kinesis data streams as they both allow for real-time ingestion of data, but Firehose can scale automatically to meet your needs and can be used to transform the data before it is loaded to your target. The next one I'll talk about is AWS Data Pipeline, which can be used for a wide variety of data sources and is not limited to only migrating databases like DMS. AWS Data Pipeline could be useful if you're loading CSV flat files into your data lake or other types of data as well. It can be configured to move data from AWS compute and storage services as well as on-prem data sources at specified intervals, so it's a fairly versatile tool. The last source-to-lake offering that we'll cover is AWS Lambda. AWS Lambda is unique from the other options previously discussed because it is used to run code without provisioning servers. This makes it incredibly dynamic as you can use a variety of languages, including Java and Python. A specific example of where we have used AWS Lambda is to get data from APIs. So now that you have data in the raw layer of the data lake, the next consideration you will need to make is how will you process the data through and eventually out of the data lake. Some typical reasons for processing data are that it is often necessary to transform the raw data and to include business calculations to turn the source data into something valuable for the business. You may also want to enrich your source data with master data information or generate additional attributes for reporting. As with moving into the data lake, there are also a number of options to carry out data transformation between data lake layers. One of the most common and frequently used options is AWS Glue. We have found that AWS Glue is pretty well suited for this task, and it's also native to the AWS platform. So AWS Glue is a serverless, scalable ETL tool that would likely satisfy most use cases. It can be configured using Scala or Python, and since it is code-based, almost any type of transformation can be carried out, making it a very powerful option. Another option for more specific use cases is Amazon EMR. It is a cloud-native big data platform for processing vast amounts of data using the open source tools Apache Spark and Apache Hadoop. Unlike AWS Glue, which is serverless, EMR requires that you have the infrastructure set up to run the tool. EMR could also make sense to use if you're dealing with extra large data volumes and need guaranteed performance for data processing. Lastly, Databricks. So Databricks is a product offering from outside of the Amazon umbrella that can be integrated into an AWS architecture. Like EMR, Databricks also uses Spark at the base and is meant for big data processing and modeling. Since it is a separate tool, there are also additional costs with getting a Databricks license. Some considerations for Databricks instead of AWS Glue are: has there been other investment in Databricks within your company? Are you planning to use some of the other functionality offered by Databricks beyond simple ETL? If the answer to those questions is no, then AWS Glue would probably be able to better suit your needs. When using AWS Glue, it is important to consider the AWS Glue data catalog. The objective of the Glue catalog is to make the data more discoverable so that you don't have users to continually look for data, or you don't have people working on different data sources believing that the one they're working on is the true source. The catalog is a central repository that stores structural and operational metadata. When cataloged, the data is searchable, queryable, and available for ETL jobs in AWS Glue. The catalog is generated when you configure AWS Glue, and records are entered by the AWS Glue crawler resource. You can classify your data for the crawler to infer the data schema and organize your data in the catalog. Additionally, if you wanted, you could stick a web-based front end on top of the Glue catalog, and that would be a one-stop shop for anybody looking to get access to any kind of data that you house. Once you have moved the data through your data lake into the output layer, you're now ready to think about provisioning it for users and creating reports. Very often in BI and A reporting, we have a semantic layer. In our architecture, the semantic layer is the Amazon RDS instance. The semantic layer acts as a go-between from the data lake and the business user reporting, combining the information from the data lake into a readable and structured manner for reporting. It often can include some calculations on the data fields that feed into the reporting capabilities or additional security controls for performance optimizations. There are a variety of database engines, both open source and commercial, that you can choose from when selecting an RDS instance. Some examples are Amazon Aurora, PostgreSQL, Oracle, or Microsoft SQL Server. The variety enables you to choose the database engine that best fits your needs. For example, if you're already familiar or use Microsoft SQL Server, you may want to consider using that as your database engine. From the semantic layer, you can then connect to a variety of tools for reporting. As Archana mentioned, you may already have existing investments in BI and reporting tools that you may want to leverage, like Tableau, Power BI, or MicroStrategy, to name a few. Amazon also offers their own reporting tool, Amazon QuickSight, to enable users to build dashboards and reports for their business. Additionally, you may have some analysts in your organization who want to run data science algorithms or just access the less processed forms of data. Amazon SageMaker allows you to do this by letting you access data from any data lake layer or from the semantic layer so that they can build and test machine learning models. The outputs from SageMaker could either be analyzed directly, or if you'd like to productionize these models, you could think about feeding them into the RDS or perhaps back into the data lake itself. Whether you're just starting off on your journey with AWS or you're looking to solve a new business problem within an existing architecture framework, a general methodology that we've found to be quite useful is, first, you want to identify the business case. If you're looking to define an architectural strategy, you may want to consider a set of varied use cases. From there, you want to know what you're shooting for. You want to define what success looks like from both an IT and business user perspective. When you have a solid understanding of the business use case and success criteria, then you want to identify the right tools. When you have those three set up, then you can quickly spin up resources and begin implementation. There's a spectrum for how to do this, ranging from getting all the requirements up front and building that system to spec, or you can start building and modify as necessary. The best solution probably depends on your needs and is a mixture of the two. Once you've created the initial system, you can then work with the business to understand if there are other areas of interest not included. So like bringing in new data sources or modifying reports. When you identify these areas, you can iteratively expand the capabilities of the system to be in line with the business goals. Alongside understanding the business requirements and identifying the right tools to meet those business needs, other considerations that are equally important and that you should think about in your journey are security, how will you manage access to the system, who should be able to access it from where, how restricted or open are your organization's policies, how do you best utilize the principles of DevOps to be more efficient and effective in your development and release lifecycle. Reusability. One of the big strengths of AWS is the code-based framework of all services. Leveraging this effectively allows you to use the framework of your architecture for other business units and other applications. Finally, monitoring and governance, enabling the right level of oversight and control to ensure that the cloud platform is working as expected and is being used appropriately and effectively. With that, we come to the end of today's session. I hope you found this useful. If you have any questions or are interested to learn more, please don't hesitate to reach out. Once again, thank you very much for joining us today, and have a good rest of your day.